This is the lesson 16 workbook. So starting with 16.1, number 1, what are the coefficients in the polynomial 55a plus 22b minus 1.4? And then it says do not include the constant term, so it's important to know what the constant term is. Constant meaning it's going to always have the same value. It's never going to change in value. So what that looks like in algebra is a number that is not being multiplied by a variable. So in this case, the constant term would be negative 1.4 because it doesn't have a variable attached to it that could change its value. So negative 1.4 would be the constant term, so we're not going to include that in our list. And then coefficients, those are numbers that are being multiplied by a variable, so like usually written in front of the variable. So in the term like 55a, just 55 would be the coefficient. And then in the term 22b, just 22 would be the coefficient. So when we're checking our answers, you'll notice that like there's a 55a and then there's a 55. The coefficient is just the number part. It doesn't include the variable part, so you would check 55. And then same thing with the 22, there's a 22b and then just a regular 22. The coefficient would just be 22, it would not include the b. And then moving down to, take that back, I'm going to add one more thing. Keep in mind that like coefficients can be negative, so this one doesn't have any, but for example, if this was like a minus 22b instead of a plus 22b, then the coefficient would be a negative 22 because the signs, like the minuses and stuff, always belong as negatives to the terms behind them or after them. So 16.1, number 2, which expressions are polynomials? So for polynomials, we're really looking at like something that breaks the rules for polynomials. So this is a list of things that they can't have. So negative exponents over variables, fraction exponents over variables, like, so negative exponents over variables would be like x to the 1/2, or sorry, negative 1 for negative exponents, and then a fraction exponent would be like x to the 1/2. So we just can't have exponents over variables that are negative or fractions, or negative fractions for that matter. It can be over regular numbers, it just can't be over variables. And then the third one, we can't have variables in the denominator of a fraction, which, remember, the denominator is the bottom. Okay, so we're going to go through each of these and just kind of like mark off which ones are not correct. So the first one, 1 over y plus x minus 1. So it has a y in the denominator, so it breaks the third rule. Can't have variables in the denominator. So that one would like not be a polynomial, so we're not going to check it. So I'll cross it off in like red. Okay, so we're supposed to check like which ones are polynomials. That breaks the rule of having a variable in the denominator, so we don't check that one. Okay, for the second one, 11ab minus 3.2a squared plus 15. So this one has a decimal, which we do have a rule about like not having fractions or like even, I'm going to add actually, fractions or decimals. But it's only a problem if it is in an exponent form over the variable. So having the 3.2 as a coefficient, that's okay. If 3.2 was an exponent over our variable, that would be a problem, but it's not, so it's okay. So this one doesn't break any rules, so we would check this one. And then the third one, 6a squared b to the negative 2 power. So this one has the negative exponent. It breaks that first rule. Can't have negative exponents over the variables, so we would not check that one because it's not a polynomial. The fourth one, 2/3 m to the third power minus m squared n plus 1/2 n squared. So basically, most of the rules have to do with the exponents. They can't be like decimals or fractions or negative numbers. They just have to be whole numbers, so positive numbers without a fraction or decimal. So all of our exponents, like this is a 3, this is a 2, this is a 1 because you don't see the power, and then this is a 2, so it's not breaking any of the exponent rules. And then the last rule is we just can't have variables in the denominator, which we don't have variables in the denominator. We just have like whole numbers, a 3 and a 2. So this one does not break any rules. So that means it is a polynomial. So we would check this one. And then the last one, 3x squared minus 5x minus 4. So no negative exponents over the variables, no fraction or decimal exponents, and then no fractions in, or no variables in the denominator of a fraction. So it doesn't break any rules, so this one would also be a polynomial. Okay, 16.1 number 3. What are the terms of the polynomial? So terms are kind of like different pieces that are separated by a plus or minus. So like we have one right here, that's 6x squared, that would be a term. And then one right here, 4 sevenths y squared. And then this like 4x, so it's this one separated by a minus, and that minus belongs with the 4x, making that term actually a negative 4x. And then the last one, the minus 45, so the minus would belong with that 45, making the term a negative 45. Okay, so each term, 6x squared plus 4 sevenths y squared, negative 4x, and then a negative 45. So on mine, it's the first option. So this one right here. So there's the 6x squared, 4 sevenths y squared, negative 4x, and then negative 45. So this answer down here is really, really similar. They just did not consider, you know, the negatives that belong with like the 4x or the negative that belongs with the 45. And if it's minus that term, that means that term is negative. Okay, so be careful which answer you pick. You should have to include the negatives if they're in your expression. And then one other thing I kind of want to point out is that this answer has all the coefficients listed. So terms include the variables also. So there's like coefficients are a part of the overall term, but the terms include the variables as well. Okay, 16.2 number 1. Stefan evaluated the sum of the polynomial 3x to the 4th power. So reading from like right here. 3x to the 4th power minus 6x squared plus 4x minus 9 and 5x to the 4th plus 3x squared plus 10x plus 2 as shown. So did he make a mistake? So what he's doing is he's taking that first expression, 3x to the 4th plus or minus 6x squared plus 4x minus 9, puts that on top, and then on bottom he puts the 5x to the 4th plus 3x squared plus 10x plus 2 like this, and then he adds from left to right. So you just want to check to make sure the setup is perfectly like exact. Sometimes they'll try to sneak in and like maybe change a variable from here to here or something like that, but they don't. Like everything is exactly as it was written originally. And then when we add polynomials this way, it's like vertical adding. We just start from left to right. So first we would do 3x to the 4th plus 5x to the 4th. We add we add polynomials by adding their coefficients. So we would do 3 plus 5 to get 8, and then the x to the 4th stays the same. So when you're adding, the powers don't change at all. And then for the next one, it would be negative 6 plus 3 is negative 3, and then it's still x squared, that stays the same all the way through. And then 4 plus 10 to get 14x, and then negative 9 plus 2 to get negative 7. So I don't see any mistakes. It doesn't look like there's any mistakes. So we can say no, all of his work is correct. And then if you're ever not sure, like you just seem like maybe it's too good to be true, just read through all of the other answers and see if like those are the case, because maybe we did miss a mistake. But if we did, it would be like within all these answers. So we can check to see if any of those should be true. So for the first one, it says the constant term should have been negative 11. So the constant term comes from adding negative 9 plus 2. Well, negative 9 plus 2, sometimes we do think it's negative 11, but it's not. It's negative 7. So if I start at negative 9 and I go up 2, I'm becoming less negative, so it would bring me to negative 7, so that one's okay. The second one, the coefficient of x to the 4th should have been negative 2 in the sum. I don't know why. Oh, maybe if, okay, so it's talking about this part of the problem right here. The only thing that I could think of that would make it the coefficient -2 is if I was actually supposed to subtract, but we're not, we're adding. So we just have to add 3 plus 5 to get 8. But that could be an easy mistake to make on like a subtraction problem, like kind of doing it backwards. And then this one right here, the coefficient of x should have been -6. So x's are right here. So 4 plus 10 is 14. So that's okay. It should not have been a -6. So we're not subtracting. And then this fourth one, coefficient of x squared should have been -9. So -6 plus 3, those are the coefficients of x squared. If I start at -6 and I go up 3, I'm becoming less negative. So it would bring me up to -3. So that's okay too. So everything looks good. All of his work is correct. Okay, 16.2 number 2 is one of those problems that it's like a few problems in one, and then we have to match the answers. So the bottom row is like all of the possible answers. We'll just go through the first 4 like kind of one by one. I'm just going to go ahead and label these as like number 1, number 2, number 3, number 4. And then once we simplify, that's kind of how we'll label the answers also. Okay, so number 1, 3x to the 7th plus -4x to the 4th plus x squared plus 7x to the 4th plus 5x squared plus -3x to the 7th plus 5. That's a big mouthful. So I want us to go through and just kind of identify what our like terms are. Remember that like terms are terms that have the same variable to the same exponent. So these all have x's, but they don't all have the same exponent, so they're not all necessarily like terms. So like right here, I have a 3x to the 7th. I want to look for another term that has an x to the 7th, which is this one. And then remember, like when you're going through and identifying like terms, like you can use shapes to like kind of group them together. Like maybe these are triangles, the next one is circles. You can use underlining, and then like the next one would be like 2 underlines, just anything that's helpful, like a visual for you to group them together. I think I'm gonna go ahead and use underlines. So this will be 3x to the 7th, -3x to the 7th, those both have x to the 7th. And then I have a -4x to the 4th and a +7x to the 4th. These will be different color and my double underline, really whatever works for you. And then for x squared, I have this 1x squared right here, and then I have a 5x squared right here. Those are like terms. And then I always like to do something that like makes sure, even if like this 5 right here does not have a like a buddy, I just don't want to forget it. So I like to underline them or put the like square on it or something, just so I don't miss it when I write my final answer. Okay, so it's always best practice to start with the highest power first when you're dealing with like only one variable as opposed to like multiple like x and y. So we'll start with the x to the 7th. So in order to combine like terms, you add the coefficients. So you do 3 plus -3. Well, 3 plus -3 is 0. So don't write this. We would not write 0x to the 7th. It's just 0. Even though there's an x to the 7th, it has a value of 0. We just wouldn't write it. So if there's like one that's a positive and one that's negative, in this case, +3 and -3, they still cancel each other out. I'm just going to cross them off. It's only the case if they're the same number, like 3 and -3, 4 and -4, and so on. And then for the x to the 4th power, that's my next highest power, I have a -4 and a +7. So I would do -4 plus 7 is 3. And then the x to the 4th part stays exactly the same. So if I combine those two terms, I would have a 3x to the 4th from adding -4 plus 7, and then x to the 4th stays exactly the same. And then next I can move on to my x squareds. So remember, if I don't have a coefficient, then the coefficient is 1. So I would do 1 plus 5 is 6x squared. And then my last one that I just can't forget about is that 5. Even though I don't have anything to combine it with, I just have to tack it on at the end. So 3x to the 4th plus 6x squared plus 5. Okay, and then this was this one right here, it's the same thing. So I don't necessarily think we need to use the bottom part, but 3x to the fourth. Oh, wait, hold on. I don't know why I did that. Oh, I just looked at the 3x to the fourth. Sorry, ignore me. It was this one. So 3x to the fourth plus 6x squared plus 5. Okay. Okay, so number 2. Same concept. We're going to go through and find the like terms. They have the same variable and the same power. So I have, let's see, an s squared at the very front, and then I have a 6s squared at the back, and then I have a negative 2t squared and just a 1t squared right here. So the t's and s's are different types of variables, so even though they're squared, they don't all combine as into one because they have 2 different letters. And then I have a 4st and then an st right here, so no coefficient, so the coefficient would be 1. And then I have another just like lone constant term that I just can't forget about. So when you have 2 variables, it doesn't really matter which one you, like which order you put it in. You just may end up in a little bit different order than like the answer is, like if it's a pre-selected answer, but that doesn't mean what you did is wrong. So I'm going to start with the s's. So this is a 1s squared, so I would do 1 plus 6 is 7s squared, and then I'm going to go on to the t squareds. So negative 2 plus 1. Negative 2 plus 1 is negative 1 t squared, but we wouldn't write the negative 1, we would just write it as negative t squared. So negative 2 plus 1 is negative 1, negative 1 t squared is written like this. And then I have 4st plus 1st, so together that would be plus 5st. And then I just can't forget about my constant term at the end of 5, so I would do plus 5. Okay, so I don't know why. Oh well, it's okay. So st squared minus 7 from the beginning. 7s squared minus t squared plus 5st plus 5. This could be, like I said, in a different order though than the final answer. So if we look at like the final answer choices that we'd have down here, the one it technically matches up with is this one. It just has the answers like in a little bit different order, and that's okay. It doesn't mean what we did is wrong, because we can always rearrange the terms. So what they have is they have the like 5st second. So if I were to rewrite it in that order, it would be 7s squared plus 5st plus, or sorry, minus t squared. Notice that the minus stays with the t squared, it belongs with it, and then plus 5. So these are the same exact answer. Okay, for number 3, x squared plus 6 plus 9x to the fourth plus 7x plus negative 6x to the fourth plus 4x squared minus 1. So let's see, like terms, I have this x squared right here, it's a 1x squared. I have this 4x squared. I have 9x to the fourth, negative 6x to the fourth. Let's see, I have a 6 constant and a negative 1 constant, so those go together. And then I can't forget about my x, my 7x, that's just kind of by itself. Okay, so starting with the highest power first, the highest power is x to the fourth. So I would do 9 plus negative 6. 9 plus negative 6 is the same thing as 9 minus 6, so it'd be a 3. And then x to the fourth stays the same. And then my next highest power is x squared, so this would be a 1 plus 4x squared, so together that would be 5x squared. And then next highest power of x is the x to the first power, so that would be the 7, and there's nothing to combine it with, so I just copy it down, so 7x. And then my constant term, 6 minus 1, so I would do a plus 5 at the end from 6 minus 1. And then altogether, 3x to the fourth plus 5x squared plus 7x plus 5, so that goes with this one down here. Okay, Okay, and then I know, like, process of elimination, there's only one answer left for 4, but I want to go ahead and go through it just so we have another example, because can't hurt. So, like terms, I have a 3t squared, and then I have a 5t squared. They both have t squared. I have a 2s squared and a 5s squared that both have s squared. And then I have a t squared y that's kind of by itself. I just can't forget it. So here, since there's 2 different types of variables, s's and t's, the order really doesn't matter. I'm going to go ahead and just start with the, like, t squared y. Oh, wait. I guess there's 3 variables, t, s, and y. Okay, anyways, I'm just going to put that first just because, like, we have the answer there, and it starts first also, so we don't have to reorder. So t squared y. And then I have to combine my s's, so that'd be 2 plus 5s squared, altogether would be 7s squared. And then my t's, 3t squared plus 5t squared, 3 plus 5 would be 8t squared. So altogether, t squared y plus 7s squared plus 8t squared, so this one goes with 4. Okay, moving down to 16.2, number 3, which polynomial is equivalent to all of that. 0.5 xy plus 2x squared minus 7y squared x plus 4y squared minus 1.2 x squared y plus halfway through plus negative 0.75 x squared plus 8y squared minus xy plus 3x squared y minus 9y squared x. Okay, I probably said something wrong in there, but you guys get the point. You can read it. So when we have an addition problem, like 2 parentheses separated by addition, the parentheses don't really mean anything. So if you want, you can rewrite the problem with them. This problem is really long, so I don't want to rewrite it, so I'm just going to pretend they're not there. That is not the case for subtraction, but for addition, it's okay. Okay, so we got to find the like terms. So I'm just going to start at the front. So there's this term that has an x and a y, and this term that has an x and a y also, both to the first power. Notice, like, I didn't say that this one was a like term. It has x and y also, but it has a different exponent, so I can't combine it. Same variable and power. And then this is a 2x squared, and right here I have a negative 0.75x squared. This has a y squared x, and then so does this one has a y squared x. And then this is just a y squared, no x. And so is this one. Okay. And then the last one. Oh, I ran out of colors. Okay, the last one has a negative 1.25 x squared y. Oh my gosh, this is a lot of lines. And then this has the x squared y also. Okay, so we have everything. Everything has a buddy. We just got to combine them. And then we'll have our final answer. So I'm going to, like, not cheat, but I want to try to write it in the same order that, like, the answers are written in. So if you look at all of the answers, they all have, like, x squared y first. So I'm gonna, one of them doesn't. Okay, well, most of them have x squared y first, so I'm gonna go ahead and combine my x squared y's first, even though, like, 2 variables, 2 different types, so order doesn't really matter here. Okay, so my x squared y's, those were the oranges. So negative 1.25 x squared y, and then 3x squared y. So we got to add negative 1.25 plus 3, which should be 1.75. So this would be a 1.75, and then the x squared y stays the same. Okay. Well, there's only one answer that has 1.75, so I'm thinking it's going to be that one, but I'm going to finish the problem, and then if we end up with something different, it'll tell us we did something wrong, so it's worth it to finish it. Okay, so the next kind of, like, variable or, like, types of variables that they have listed, some of them have the, why did they do this to us? Okay, I'm sure you guys are feeling the same pain that I'm feeling right now. Some of them have the y squared x, and then some of them just have x squared, so I think I'm going to go with the y squared x next, which is my purple. So -7 y squared x, and then -9 y squared x, so I have to combine -7 and -9, which if I do -7 plus -9, that's -16, and then y squared x. And then I'm going to move on to, I kind of want to, like, it's looking like it's going to be the second option, so I'm just going to keep my variables, like, in that same order that they have, and hopefully it ends up being the same exact answer. So next is x squared. So I have a 2x squared and a -0.75x squared, so 2 plus -0.75 is 1.25, so it'd be 1.25x squared. Still doing okay. And then next in that kind of like set of variables or order variables is xy, so I'll do my xy's next. And then I have a 0.5xy and a -xy, which means -1. So I would do 0.5 plus -1, which is -0.5. And then the xy stays the same, so that's okay so far. And then the last one that we have left is the like 4y squared plus 8y squared. I guess they saved the easiest part for last, but if we do 4 plus 8, that's 12. And then the y squared stays the same. So cool, it ended up matching up exactly the same as that answer. So altogether, it was, sorry. Its stuff is not cooperating today. So 1.75 xy squared, 1.75 xy squared, or sorry, x squared y, -16 y squared x, -16 y squared x, 1.25 x squared, 1.25 x squared, minus 0.5 xy, minus 0.5 xy, and then 12y squared at the end. So if your brain is like on fire like mine is right now, I feel like that was just a lot of the saying the same letters over and over again. Maybe pause the video for a second and like reset before you go on to the next problem. Okay, so 16.2 number 4. So Marco added the polynomials. Okay. He added the polynomials 1/2 x squared plus 3/4 x to the 6 plus 14 minus 1/2 x, and 1/2 x plus 1/2, or sorry, 1/4 x plus 1/2 x squared minus 5 minus 1/2 x to the 6, and he found the sum as x squared plus 1/4 x to the 6 plus 9 minus 1/4 x. Which answer represents the polynomial? Okay, so he got the answer correctly. We're not asked to like find a mistake. We just have to make sure it's in the correct order, which is cool. So which answer represents the polynomial x squared plus 1/4 x plus 9 minus 1/4 x, sorry, x squared plus 1/4 x to 6 plus 9 minus 1/4 x, rewritten in descending order? So really, we just need to know what descending order means and like specifically what descending means. So descending is like counting down. So like 5, 4, 3, 2, 1. And when it says descending order, it's referring to the variable exponents. So variable exponents in descending order. So as obnoxious as this problem was with all the fractions and stuff, we just have to make sure that it's written in the correct order, which starts with the highest exponent and it goes down from there. So if I look at my 4 terms, the highest exponent is the x to the 6th power. This is like, this one has x squared, this one has no exponent at all, and this is x to the 1st power. So I would have to start my expression with the 1/4 x to the 6th. And then the next highest power is this x squared. So next I would put plus x squared since it's a positive x squared. And then next I would put the x to the 1st power. So since there's a minus in front of it, it belongs to it. So I would do minus 1/4 x. And then always last in descending order would be the constant term. So the plus 9 at the end. So altogether, 1/4 x to the 6 plus plus x squared minus 1/4 x plus 9. And that looks like on mine it's this one. Okay, I'm sorry, I probably butchered a lot of those fractions by like switching my 1/4 and 1/2. But biggest thing for this problem is just understanding what it means for something to be in descending order. That means that you count down from the highest exponent to the lowest. So 6, 2, 1, and then always the constant term at the end. Okay, so last workbook, 16.3, number 1. So Gilbert evaluated the difference of the two polynomials as shown. So it's another one where we need to find the mistake. This time he does it horizontally. In the first problem like this, he did it vertically. I think it was 16.2, number 1. So this is just structured a little bit different. So we're going to go through each step and then we'll kind of look at the possible responses. See if we actually like find a mistake. So this section now is subtraction. So the first step that you take with a subtraction problem is you take the first set of parentheses and you copy it down exactly as is. So 2x to the 5th plus 6x to the 4th plus 2x squared minus x plus 8. That's what he did right here. He copied it down exactly as is. And then the second thing that you do is you have to take this negative, and you can think of it as like a -1 if you want, and you distribute it to the second parentheses. So you would do -1 times -4x to the 5th. When you multiply a number or a term by -1, it doesn't change anything except for the sign. So it changes positives to negatives and negatives to positives. So if I do negative or -1 times -4x to the 5th, then this should have became a positive 4x to the 5th. And then -1 times 7x to the 4th should have became a negative 7x to the 4th. -1 times 9x should have became a negative 9x. And then -1 times -5 should have became a positive 5. So all of the signs in the first parentheses should have changed. A negative should have became a positive should have became a negative, positive should have became a negative, and a negative should have became a positive. That's always the case for a subtraction problem with polynomials. Everything in the second parentheses you have to distribute a -1 to, and then it changes to a problem where we're just combining like terms, and the rest of the process is the same as addition, but we have to do that first step first. So that's his mistake. He didn't do that. So for that answer, it's the third one. It says, yes, he did not distribute the -1 over the polynomial -4x to the 5th plus 7x to the 4th plus 9x minus 5, the thing that was in the second parentheses. Okay, 16.3, number 2, what is the difference between 24a plus 32b minus 7 and 13a minus 8b plus 5? Difference means subtraction, means minus. So we'll set this up as a subtraction problem. It'll be the first one, 24a, plus 32b minus 7, and then minus, because it says difference, and then the second part, 13a minus 8b plus 5. And yes, they do need to go in parentheses. At the very least, the second one would have to go in parentheses. Because if you don't, then you're not distributing the negative to the entire thing. It basically would mean that you weren't subtracting all of the second expression if you don't put it in parentheses. You would just be subtracting part of it. So now the next step is to copy the first parentheses down exactly. So you do 24a plus 32b minus 7, and then we think of this like minus as a -1, and we distribute it to the second parentheses. So we would do -1 times 13a, that turns it into a -13a. -1 times -8 turns it into a positive, 8b, turns it into a positive 8b. And then -1 times a positive 5 turns it into a -5. So what happens when you distribute the negative is all of the signs change. So the positive 13a became a negative 13a, and the positive 8b became, the negative 8b that we originally had became a positive 8b, and then the positive 5 turned into a negative 5. All the numbers stay the same, just positives to negatives, and negatives change to positives. And then now it becomes an addition problem where we're combining like terms. So like I have my a's that I'll end up combining. I have my b's that I'll end up combining. And then I have my constant terms also. So now I combine them by adding or subtracting the coefficients. So I would do 24 minus 13, that's 11a. And then 32 plus 8, that's 40b. And then negative 7 and negative 5 together, if I have 7 negatives and I combine it with 5 more negatives, then altogether I have 12 negatives, and that was just the constant, so there was no variable. So on mine, the answer is the first one, 11a plus 40b minus 12. Okay, and then 16.3, number 3, I think this is the last one. Yeah, it looks like it. Okay, so another kind of long, obnoxious problem, but the process is the same, even though it's a little bit meh. Okay, so we're going to do 29r to the 4th minus 11r to the 3rd power s plus 5r squared s squared plus 19r s cubed plus 4, and then minus 20r to the 4th minus 10r cubed s plus 13r squared s squared plus 14r s cubed minus 33. So my biggest recommendation for a problem like this is take your time. Like, you're going to do the problem anyways, you might as well spend a little bit more time just to make sure that it's right and that you are getting something out of the work that you're putting into it. So the first step is to just take everything in the parentheses and copy it down exactly as is. So 29 r to the 4th minus 11, and then that was r to the 3rd power s plus 5 r squared s squared plus 19 r s to the 3rd power, and then plus 4. So at this point, I would stop and just like look, double check, make sure you copied it down exactly. I don't see any mistakes, so I'm going to move forward. And then the second step is to think of this as a negative 1 and distribute that negative 1 to everything in the second parentheses, changing its signs. So it'd be like negative 1 times 20r to the 4th, that'd be negative 20 r to the 4th. Negative 1 times negative 10r cubed s, so that would turn the negative into a positive 10 r cubed s, and then negative 1 times 13r squared s squared, so that would turn into a negative 13 r squared s squared, and then negative 1 times 14r s cubed, so that turns into a minus 14r s cubed, and then negative 1 times negative 33 turns into a positive 33. So just make sure that you end up with like the correct amount. So we have like 1, 2, 3, 4, 5 terms that we just distributed, and that got me 1, 2, 3, 4, 5 terms. And then also double check that, you know, your negatives turn to positives and your positives turn to negatives. So this was positive, it turned negative, negative, turn positive, positive, turn negative, positive, turn negative, and then negative turned positive. But all the numbers stayed the same. And then now we're ready to just go ahead and combine like terms. So really that first step is the only thing that's different between this and an addition problem. So we have, let's see, 29r to the 4th and negative 20r to the 4th. And then I have negative 11r cubed s. And then I have a 10r cubed s, 5r squared s squared, negative 13r squared s squared, 19r s cubed, we're getting close to the end, negative 14r s cubed, and then the constant terms, 33. I'm just going to put like a little V shape under those. So 4 and 33, those are constant terms. Okay, so I'm going to start with the r to the 4th powers. So I'm just going to pretty much keep them in the same order that they were written. So r to the 4th power first, so 29 and negative 20. 29 plus negative 20 or 29 minus 20 is 9. R to the 4th. And then negative 11 and positive 10. Negative 11 plus 10 is negative 1. So if I'm like at negative 11, I go up 10, it brings me to negative 1. But I don't have to put the 1 in front. I would just put minus r cubed s. And then 5 and negative 13. If I do 5 plus negative 13, that's negative 8. And then the r squared, s squared stays the same. And then 19 plus negative 14, that's the same as 19 minus 14, which is 5. rs to the 3rd power. And then I have my constant terms, the 4 plus 33, so together 37. So 9r to the 4th minus r cubed s minus 8r squared s squared plus 5rs cubed plus 37. Looks like the 3rd one on mine. Yeah, those are exactly the same. Okay, so biggest thing with subtraction, you have to distribute the negative first, and then after that you combine like terms.